everybody, my name is Josh. I was a computer science examiner for multiple exam boards, head of computer science for UK based schools, and now I run a tutoring business where I've helped thousands of students to get better grades in computer science related courses. Now, what we're going to be carrying on with is the data types unit, and it's all to do with the normalization, and we're also going to look at how to convert a number, a denary number, into a floating point number. But first of all, we just need to tie it all together with the normalization part here. So with normalization, if we relate this to standard form as a mathematical concept, let's say that we had this. Okay, so 10 to the 10 to the power 4. This isn't normalized. So for it to be normalized, we need to move the decimal point in between the 3 and the 4. And then we need to, because we've made this number bigger, we need to make this number over here smaller. That is now normalized. And it's the same concept in floating point binary. With floating point binary, the two things that have to happen is it either needs to be, if it's a positive number, 0, 1. And if it's a negative number, it needs to be 1, 0. So you can see that both of these situations, that neither of them are 0, 1 at the front. So how we do this is we're going to move it. We need to move the decimal point so it's 1, 2. Put that in there like that. And then we're just going to add 2 zeros at the back. So we're going to go just the rest of the number here, and then 2 zeros at the back. Now, because I've made this, I've essentially made this number bigger. I've made the mantissa bigger. I need to subtract 2, or however many times I've moved the decimal point away from the exponent. The exponent there is 3, so 1, 2, 3. So I need to subtract 2 from that. So now it equals 1. For the next one, for a negative number, we need to make it 1, 0. So we need to get rid of these leading ones. And that's sometimes what confuses people a little bit. So what we're going to do is we're going to go 1, 2, 3. Then what we're going to do is we're going to put the numbers in like so, and then we just, because we moved it 3 places, we're going to put in 3 zeros, so 0, 0, 0. Now because we've moved it 3 places to the right, we have to subtract 3 away from our number up here. This number here is 4 and 2, so 6. We subtract the 3 away from it, so that's going to give us 0, 0, 1, 1, because that's how we get 3. Finally, tying this all together is we have to go through a process of normalization to convert if we have a denary number, for example, 78, what we have to do is we have to go through a process of normalization to do it correctly if we want to convert it into a floating point number. And we want 8 bits for the mantissa, 4 bits for the exponent. So first, step 1 of what we're going to do is we're going to convert it into a 8-bit number. So we'll just do that. So 64. So 64, take that away from there, which is going to leave us with 14. Okay, so we've got 32, 0, 16, 0, 8, 1. Take that away from there, which is going to leave us with 6. We then keep going with the 6. So then what we do there is then we've got 8, 4, 2, 0. Okay, so that is there that we've converted the number into an 8-bit number. Now, because the decimal point is here, what we have to do is we have to move the decimal point so it's going to equals 0, 1. So what I'm going to do is I'm going to move it. I need to count how many times I move it to the left. So 1, 2, 3, 4, 5, 6, 7. So I've had to move that 7 places. Redraw my number. And then that's 8 bits for the mantissa. If I needed to use more bits, then I just add in zeros. And because I've moved it 7 places, that is then going to give us 1, 1, 1. So that gives us the 7 for the exponent, and then the 78 normalized in the mantissa.